And I have a quick announcement to make. Assignment 2 is coming out this afternoon. It's just about done. There's just one more question that needs to be written up. It's going to be due next Wednesday, I think. Does that make sense for this course? Wednesday. Sorry, just let me pick. Yeah, it's going to be due next Wednesday. Oh, actually, that's awkward. Wait, no, Wednesday's fine. Okay, so it's due next Wednesday for this course. Sorry, there's teaching too many courses. I keep on getting confused between which course is which. So it's due next Wednesday. There's no late assignments won't be accepted this time because I need to or I want to post the solutions for the assignment immediately because you have a midterm next Friday. Now the midterm, the date has been on queue for some time now, but it's been wrong. It was on the Sunday for some reason. And I didn't realize that it was incorrect until someone asked me about it last night. The original date was Sunday. It's actually the Friday, and it's during the lecture time. It's on queue. Now, if you can't, if you run into an issue in assignment 2, so for example, if you get sick or something like that, or something comes up, just let me know, and then we will come to some arrangement on how to deal with assignment 2, so that you don't get overly penalized for missing assignment 2. Because normally you'd be able to hand it in late, but you can't this time. And other than that, that's all the announcements I have. I noticed that when I was reviewing what we had done in the lectures, that we missed part of a lecture before before arrays. So I noticed that when we were doing the array stuff, that we were using loops, and I thought, hey, I don't think we've actually talked about loops in the course, and in fact, we hadn't. So I have to go back and tell you how to write a loop in Bash. Fortunately, it's not terribly difficult. So Bash has 3 kinds of loops. There's a while loop, there's an until loop, which is sort of like a while loop, and there's a for loop. And the for loop has 2 different versions. Oh, sorry, where can we find the slides? The slides are, let's see, shell scripting number 4. So it should be lecture deck 10, or lecture slide 10. So they're all there. So they're the same lecture slides as last term. So yeah, they're already there. Okay. A while loop runs the same as in any other programming language, right? There's some condition, which you know in Bash is a command. So the loop runs as long as that condition is true. A while loop will run 0 or more times, right? So if the condition's not true, it doesn't run. Until runs as long as the test command has an exit status of non-zero. So until runs 1 or more times, right? So in other words, the condition is checked at the, just quickly jump ahead. Runs as long as test command has an exit status of non-zero. Until, well, I guess that's not true. I guess that can run 0 or more times too. All right, let me fix that now, because I'm going to forget if I don't fix it later. Runs 1 or more times. Conditions checked at the beginning, so that can't be true. So while runs as long as the condition is true, until runs as long as the condition is until a condition is true. And then for has 2 different versions. So there's one, which you saw, we talked about arrays. So that will run once for each string in a list. And then there's, oh, sorry, I think you saw the second style. So you saw the C or Java style of loop where you used a counter. So a while loop is while, right? And then the usual condition for a bash command, right? For a bash loop, right? You use a command here. The body is do commands, right? So whatever commands you want to do while the command condition, sorry, whatever commands you want to run in the loop body comes after do, and then the loop ends with a done. So the while loop runs as long as that command has an exit status of 0, right? So remember, that's how conditions work in Bash, right? You look at the exit status of whatever that command is. Right? And so the while loop can run 0 or more times, right? So if your command, whoa, what happened? That's interesting. So if the command here is not true or has an exit status that's not 0 the first time it's run, then the loop doesn't run. Here's how to count to 0 starting from 10 using a while loop. Right? And I don't think I have to run this because this looks the same in pretty much any programming language. Start out with a count of 10. Right here, I'm using the round brackets because I have I'm comparing something to an integer value. Right, so I'd rather use the round brackets if I'm working with int values. You can use the square brackets as well, but then you have to use one of the funny operators, right? So you would use square bracket, count minus NE, so not equal to, right, 0. And then you just echo out the count. Right? Each time through the loop, you need to, in this case, we have to adjust our loop variable ourselves. So you can write count minus minus, but again, that's an arithmetic expression, so it has to be inside of round brackets, double round brackets. If you want to use an arithmetic substitution instead, you can write it like this, right? So again, double round brackets, $sign to get the value of count, right? So count minus 1, and then store that back into count. Count minus minus, that already modifies the variable count, so you don't need to store it back into count. Right? If you want to write it either way is fine. It doesn't matter how you want to write it. One uses the, but this one here uses the arithmetic substitution. Here's the collats conjecture. That's probably hard to read, so I'm just going to show you it in an editor. It should be a little easier to read, especially if I change font size for you. Okay, so for those of you who don't know what the collats conjecture is, basically you start out with some integer value, some positive integer value n, and then while the, or val in this case, right? So let's just look at the loop here, right? So while your value is, oops, sorry. Why is it doing that? Stop that. Okay. All right, so while your value is not equal to 1, you're going to check whether or not the value is even or odd. So if the value is even, right, then you're going to update value so that it's equal to value divided by 2. Right, so there's my arithmetic substitution. Right, so double round brackets with the $sign in front. I'm going to compute value divided by 2, and then I'm going to store that value back into val. If the number is odd, then you're going to compute 3 times the value and add 1, and then store that back into val. Right? So again, use an arithmetic substitution to compute the value of 3 times val plus 1, store it back in val. Right? And this loop just keeps on running until value or val reaches the value of 1. Right? So this is a famous mathematical conjecture. So a conjecture is something, so the conjecture is that you will always reach 1 no matter what value you start with. Nobody knows if this is true. So they've tried this for very, very large values of val, and it seems like you always reach 1, but no one's been able to prove that this is in fact the case. If you run it, the way you run the program is it's just collats, and then you pass in some integer value, right? So the goal is to get to 1 starting from some positive value. So if I start at 2, I get to 1. Start at 2, 2 is even, so you divide it by itself. You divide by 2 and you get 1. And then that's the stopping condition. Right? You start at 3. 3 is not even, so you multiply 3 by 3 and add 1. That gives you 10, and then you repeat. Right? 10's even, divide by 2, you get 5. 5 is odd, so multiply by 3, add 1, you get 16. As soon as you reach a power of 2, you're guaranteed to get to 1, right? Because you're just going to divide by 2 every time. So that's guaranteed to get to 1. And if you choose some relatively small numbers, you can end up with a very long sequence. So if you start with 27, it turns out it takes a long time relative to the 27 to actually get back to 1. Right? And so this is one of the reasons why no one knows if the, well, this is an illustration of why no one knows or no one has been able to prove that you always get back to 1. Right? I can start at 27, but eventually, I mean, somewhere during the sequence, you end up at a very large number. And that's because of this line here. Okay, now this script is notable for a bunch of other reasons. So it's basically using everything we've talked about so far. We've got input. We've got some input validation here. Actually, we have input validation right here. So we're going to, so when the script starts, we're going to check, is the number of inputs equal to 0, right? So sorry, is the number of command line arguments equal to 0? Right? So if the number of command line arguments are equal to 0, we're going to use the read command and ask the user to enter a positive value. If the number of command line arguments is not 0, we're going to take the first command line argument as our value. Okay. Now, the user can type in whatever they want as the command line argument. So we're going to check, right? Is the value, right? Does it match the regular expression, right? So equals tilde, right? That's going to do our regular expression matching, as long as you're inside double square brackets. Right? I want to check, is value actually a signed integer value, right? So we know that the regular expression for a signed integer value looks like that, right? Just let's quickly review that. So remember the caret, that's the start anchor. So the so it has to start with, right, one of these two things inside of the square brackets, right? So either the minus or the plus sign, right? Question mark says whatever is in here is optional, so it can appear 0 or 1 times. So does the thing start with a minus sign, plus sign, or neither, right, or nothing, right? Followed by a digit, right? Plus means 1 or more, right? So 1 or more digits. And then the $sign means that it has to end. So that's how you check whether or not val is a signed integer value, right? And I'm interested in the case if it's not a signed integer value, so I can negate the result of the command of this evaluation outside. So if it's not a signed integer value, we're going to echo out an error message, right? And we're going to redirect that error message to standard error. Right? So remember, echo normally sends its output to standard output. I want to send it to standard error. And then we're going to exit with a non-zero exit status to indicate that the program has exited with an error. If I reach line 11, I know that val is an integer value. I don't know if it's negative though, or 0. So I'm going to check, is it less than 1? And if it is, again, we're going to print out an error message to standard error, and then exit with a non-zero exit status. And then the rest of it is just the actual loop. So there's an example of a while loop and a bunch of other stuff that we've done so far in the course. This would be an example of a fairly difficult midterm question. If you're looking, I'll post more examples of midterm questions shortly, but this would be an example of a fairly long midterm question. Okay, until. So the until loop is more or less a while loop, except you're going to check the loop runs as long as that condition has an exit status that's not 0. Right? So the while loop runs while some condition is true. The until loop runs until that condition becomes true. So if that thing evaluates to true, right, or has a exit status that's 0, then the loop stops, right? Otherwise it runs. So that should be, again, that's dumb. I don't know why I put 1 in. That doesn't make any sense. The condition's checked at the beginning, so it runs 0 or more times. So there's your until loop that counts down to 0 starting from 10. So until the count becomes less than 0, right, it's the same stuff inside the loop. Print out the count and then decrease the count by 1. The for loop has 2 different forms. There's one which is sort of looks like a for each loop, right? But it's a for each loop where the where it loops over each string in a list of words, right? So when each time through the loop, that variable there takes on the value of a word in the list. Right. So again, it's easier just to see an example. Right. So that's how you can write a list of stuff in Bash. It's just some string, space some string, space some string. And for I in the list ABC, right, it's going to print out the value of I. So it's going to print out A, then B, then C. So that value I just takes on the value of each one of those strings that are in the list. Okay, so that'll print out A, then on the next line B, the next line C. So you can generate a list in lots of different ways in Bash, right? So basically any string with a bunch of spaces in it, that's a list. You can use a path name expansion, right, to generate a list of stuff. Right? So you can write for I in Z star, right, about the value of I, and then end the loop. So if you do this in your bin directory, or at least on a Ubuntu, in Ubuntu, I don't know if you get the same thing if you get the same result on Mac. So if you're in the bin directory, there are a bunch of files, right here, that start with Z. Right? So for I in Z star, right? So Z star matches anything, any file name that starts with a Z. Echo $I. These are file names, so you really should quote the I in this case. Done. You get all the file names that start with Z. Okay. Now, you have to be a bit careful when you do this, because it's possible that you use a wildcard expansion that doesn't match anything, right? So there are no files here named ZZ. Right? So if I change this to for I in ZZ star, right? This prints out ZZ star. Right? So in other words, if that wildcard expansion does not match any file name in the current directory, then the value that's taken here is just whatever this string is, right? So that string is just ZZ star. So in this case, now you get that, which isn't what you want, which is probably not what you want to do if you're processing files in a directory, right? If you're processing files in a directory, you don't want a non-existent file name, right? So you have to check, does this thing actually exist in the directory, right? So to safely do this, you should check, right? Is that string, right? Is that actually a file in the current directory? Is it the name of a file in the current directory, right? That's what -e does. So -e is, does that file name exist, right, in the current directory? If it does, then you can go ahead and print it. Otherwise, do nothing. Right? So you have to be a little bit careful about wildcard matches that don't match. Right? If it doesn't match, then you get that string. Right? If you do get a match, then you get whatever the name of the file is. Right? And it's the same thing with the question mark. If you want to write a C-style loop, then just use this form here. Right? Sorry, a Java-style loop where you're using where you're counting. Right? Then just use double bracket, and then the same expressions that you would use to write a Java-style counting loop. If I want to count from 1 to 10, 0 to 10, sorry, 0 to 10 using a loop, then you can use the counting style for loop. Same way that you would use, you would do it in almost identically to how you would do it in Java. Right. So that shouldn't be. Everybody here should be able to read and write this kind of loop. Counting down is the same thing. Counting down to 0. This is actually wrong because that should be greater than or equal to. This will count down to 1. So that should be greater than or equal to 0. That too. So that's the stuff that I missed before. That's the stuff I should have covered before we talked about arrays. Any questions about loops? I guess the important. So I mean, obviously, if you want to do a counting style loop, that's pretty straightforward. You should remember this form of the loop, right? If you want the other form, the for each form of the loop is also pretty important that you understand how to do that, right? So if you want to loop over all the files in a directory, right? You can write for I in star, right? And then you have to make sure that, and then check if the file name actually exists. So that's the easy way to loop over everything that's in a directory. All right, so we were talking about functions at the end of the last lecture. And functions in Bash are a bit funny. So when you write a function in Bash, it's one of two forms, right? You should pick one form and then use it always. So don't mix them up. So in other words, if you want to write function name, do that. If you just want to write the name of the function followed by round brackets, do that, right? So don't do both in the same, certainly not in the same script anyway. There's an example of a simple function. When you run a Bash script, if it sees a function, it doesn't run the function, right? So it skips over the function and then it comes down to whatever's after, right? If you have a function down here, then the way this program would work is it goes, so it's an interpreted program, so it reads line by line, right? So it skips over the function, that calls the greet function. If there's another function down here, that function doesn't run, right? Unless it's called. So to call a function, it's just the name of the function. You can pass in some arguments, but we'll see an example of that later. So here, this one just prints out hello. Functions have access to other variables in the script as long as the line that defined the variable, or that defined or set or used the variable exists, or has run already, right? So here, you've got the greet function. Inside the greet function, it uses the variable called var. Now, down here, where the script actually starts running, right, var is set to the string global, and then the function is called. When you call the function, the value of var here happens to be the string global. Now, this gets a bit strange. You have to, in order to figure out what a bash function is doing, you have to trace the sequence of steps that led to the function call. So this is one way to write a bash function. This is one example of a bash script. I'm not saying it's a good example. I'm just using this as an example to show you how variables or how bash figures out what you mean when you say var greet here. Right, so here's a function, here's a function. this is where the program starts, or where the script starts, right? So var gets set to global, and then we call the greet function. So up we go to greet, right? Here we print out hello var is, and then whatever the value of var is, right? So var was set here, so that's global, right? Now this function creates its own variable called var greet, right? And sets the value to the string greet, right? Now once this variable has been created, anything else in the script has access to that variable. So if you call the leave function now, right, leave prints out goodbye, and then var greet is, and then whatever that is, right? Well, that's going to be the value greet. Then after calling, so after leave finishes, we return back to here, right? Now leave's done, so we come back to here. And now when you print out var greet, well, var greet also exists, right? So you also get the value var greet. So in other words, that thing there, that's not local to the greet method, right? That's visible to anything inside the script after this point, right? So after this line is run, var greet has that value there, right? If leave changes the value of var greet, right, then the value of var greet changes, which is a bit odd, but that's the way it works in Bash. So that's greet 3, I think. Yeah, that's greet 3. Oh no, that's greet 2. Here we go. So we have greet 2. So there's a program there. If you run it, oh, what's going on? Oh, I'm in the wrong directory. Oh, sorry. Greet 2. Right. So hello var is global. So why does that happen? Because the script starts running here. Var gets set to global. We call greet. Greet prints out the value of var, which was set here. So you get global. It then sets the variable var greet and calls leave, right? And then leave prints out the value of var greet. So it says goodbye, var greet is greet, right? And then we come back down to here, and then we print out the value of var greet, right? So var greet is also greet. Now remember in Bash, when you use a variable the first time, it gets declared, it gets defined at the first point of use. So you make a typo, right? So instead of var, you accidentally type in, I don't know, v instead, right? Your program still, your script still runs. It just doesn't do what you want it to, right? So now you get hello var is nothing, right? Because v has no value at this point. So Bash creates the variable v at this point and does not set its value, right? So it's, I guess its value is null, right? So hello var is nothing, right? You have to be careful about this, right? So if you misspell a variable name, the variable gets created for you automatically at that point. So the correct program here is to use the name var. That's one of the things you have to watch out for when you're debugging your scripts. Right? Back to here. Just a second here while I let my cat out of the room. Come on, out you go. There you go. Now, it is possible to create a local variable, but it's strange how it's a little bit strange how it works. So here I've got a variable called var, right? We set its value to global. Then we call the function greet. So we come up to here. Now greet says that there's a local variable called var whose value is greet, right? So this version of, so this name var hides that var inside of this function, right? So in other words, when you print out the value of var, that's going to be that and not global. Now when we call leave, jump down to the leave function, right? leave function also has its own local variable called var, right? So it's going to set version of var to leave. So when it prints out var here, you're going to get leave. Back up to here and then come back down to here. What's the value of var? Well, it's going to be that, right? Because that function created its own local version of var, and that function created its own local version of var. It is possible to have local variables. Boom, there it is. And if you run this program, you get the following. Right. So, oops, sorry. So we set var to global. Up here, the local version of var is set to greet. So you get hello var is greet, which we do. Right. We then call the leave function. The leave function also has its own local version of var. And so when you print out that value, you get leave. Right. Now this function finishes, we come back up to here, right? Greet now finishes, so we come back down to here. And now when we print out var, it's that version, right? So you get global. Now, what happens if you change, if you don't make this, whoops, sorry. If we don't make a local variable var, but instead we set var to that. Okay. So now let's see what happens. Okay, so now it's, all right, so let's trace through what's going on. And so this one's especially confusing. Right? So here we got var, right? Its value is global. We call greet. Now greet creates its own local variable called var, right? So we get hello var is greet. And then it calls leave, right? Now leave sets var to the string leave. Okay? So when it prints it out, we get what we expect. Now the question is that var, or is it that one, right? Well, it turns out it's the local one that was called up here. Right? So for example, instead here, of this again, we'll see that it was the, see that it's that version of var that gets changed, right? So now we get, so when it prints out the first time, you get greet, right? You call leave, you get leave, right? Now leave changes var, but it's that version of var that changes. So when you print out var is now, you get leave, right? And the original version of var is unchanged. So the bash local variables are not exactly local. Right? So they're not the same thing as a local variable in Python or Java, for example, right? In other words, var here is not local to the function here, right? It's local here, but it turns out it's the same variable. When you use var here, it's that version of var that's here. Now, what happens if you call leave from down here, right? So if you call leave from down here, then when var changes leave, it will actually change this one, right? So instead of calling greet, if I call leave, right? Now when you write var equals leave, it really does change this one. So that's also kind of confusing. You have to be a little bit careful when you're passing around information this way. All right, so why not parameters, right? So, well, it turns out they can have parameters, but functions, the parameters are not named. So the way the parameters are handled is that they're handled using the $1, $2, $3, right? So just like you use command line arguments, inside a function, you can now access the parameters by using the positional parameters. And calling the function looks exactly like executing command with command line arguments. Right. So here's an example of what I mean by all of that. Here's a function called test. Right. Test has 3 parameters, or test wants to make use of 3 different parameters. Right. So $1, $2, and $3. Right. You can get the number of arguments that were actually passed to the function. You can ask for the number here and get the number of arguments that were passed, right? And then I can print out what the values of the parameters are here. If you call the function, right? So suppose this has 3 parameters here. If you call the function here with no parameters, right? Then these 3 variables are still created, right? There's no $1 though, right? So I'm going to call test with no parameters. So there is no $1. There is no first parameter. There is no second parameter. There is no third parameter. Param1, param2, and param3 will just be all. I guess they're all null, right? So they all have they're all no value. Okay, so when you print them out, you're going to get param1 equals nothing, param2 equals blank, and param3 equals blank. Okay. So the first call to test prints out this. So no arguments are passed to the function. The value of param1, param2, and param3, well, they're all empty. Right. Now, I'm going to call the function test with 1 parameter. Right. So this looks exactly like you would write a bash command. Right. So it looks like you wrote the command test followed by a command line argument. So as far as the test function is concerned, there's now 1 argument passed to the function, and the value of param1 is a. Right. You can call a test with 2 parameters. Right, and you get this. Right, you can call it with 3 parameters, so that line there, and you get that. Right, and you can pass extra parameters to the function. Right, so I can pass 4 parameters to the test function, but we're only using 3 of them. So this is different than arrays, right? So when you create an array using, how do we create that array? Oh, when you create an array using read, all of the, so if you read in, sorry, not an array. If you use read to read into 3 different variables, right? Then the first string gets put into the first variable, the second string gets put into the second variable, and then everything else gets put into the third variable. So that doesn't happen with parameters, right? So in other words, when you pass in 4 values, right? Param3 is still the C, right? It's not the CD. Right? The D up here ends up being unused by the function, even though you passed in the D. So that's parameter passing, right? They're unnamed, which is a little bit unusual. Returning a value from a function is even stranger. So the return value of a function, so this is really weird, is the exit status of the last command executed by the function. So just let that sink in for a second. The return value of the function is the exit status of the last command executed by the function. Right? So what that means is the return value from the function is always an integer value, right? That's equal to 0 or greater, right? Greater than 0. Because the exit status is always supposed to be 0 or positive. Now, if you have a function and you want to return a string, right? Then there's not actually a good way to, there's no way you can actually do that, right? So instead, you have to sort of fake things out. You have to simulate it. So what you do, if you want to return a string from a function, is you echo the string to standard output. And then when you call the command, you use a command substitution to capture the output, which is also strange. So here's the, oh, sorry. Here's a function, right, that computes the power, that computes x raised to the power y. Right, now you would never do this in bash because you could just write that, right? But if you wrote a function to do this, then you have a problem, right? So POW can't return that answer. Actually, in this case, it can, but it would be weird how you. No, you can't. Sorry, it can't return that value, right? it can return the exit status of this statement. Here, the exit status of this statement is going to be 0 because that is going, well, if x and y are actually integer values, the exit status of this of that statement will be 0 because it always succeeds. So what you do instead is you echo that value to standard output. So that will get printed to standard output. Now, when you call the function, you use a command substitution to capture the standard output value, right? The string that's printed to standard output. So here you wrap things up in round brackets and $, right? So that's command substitution. So whatever POW prints, that's the value that you get, right? It stores that value in the string Z, and then you can echo Z. Or you can use the value of Z to do something else, right? I guess that might have been a better example. So, so I can compute 2 to the power 5. That prints out 32. Right? I guess a better example here is to use Z for something else. Right. So for example, let's compute Y equals. So let's use Z and add 1 to it. And then we'll echo $1. Right. So I'm going to call POW to evaluate that raised to the power of that. And then I'm going to add 1 to the value and store it in Y. Right. So I get 32 and 33. That's what we expect. Right. So that's the other strange thing about a bash function. Right. There's not really a mechanism. The return value mechanism is unusual. Right. It's the exit status of the last line that was run. And then, oh, I guess I should illustrate that too. So let's call POW here. POW. And then $1, $2. Oh, there's something else. Oh, never mind. It's fine. So now I'm going to call POW. We'll call that function there, right? It's going to print the result there, right? I'm not going to capture the answer, right? So I'm just going to let the value get printed to the screen. Oh, sorry, hang on. And then I'm going to echo out $? Right? So, oh, hang on, sorry, there's a better way to do this. Can I do that? No, I can't do that. Echo $? Right? So I'm going to print out what was the result of that command there. The result of running that command, of calling that function, was 0, right? So in other words, that function exited cleanly without an error. So bash functions, it does have them. They're a bit odd, right? The command line argument, the parameters you access using the positional parameter notation, so $1, $2, $3. And then the return value is either the exit status of the last command in the function. Well, sorry, the return value is the exit status of the last command in the function. If you want to capture, if you want to return some other value, then you have to print it and then capture the printed value using a command substitution. It's not, so when you think about it, it's actually not that strange. So a function, you can think of it as just being another command. It just happens that command happens to live inside of another, it happens to live inside of a script. Right, so the way to think about this POW function here is that POW is just another command, right? Bash, what's the, if you want to print something, right? If a command outputs something, then it just prints it to standard output, right? And the exit status of the program, of the command, and every command has an exit status, right? So POW has an exit status that happens to be equal. The exit status happens to be equal to the last, the exit status of the last command that's in the function. yeah, that's it for the function stuff. So I don't think it's worth starting the final scripting lecture. There's only one more scripting lecture, and then we're basically done with Bash in the course. So I'll just leave it at that. Does anybody have any questions about loops or functions? All right. So as a reminder, remember to look out for assignment 2 coming out this afternoon. It will be out this afternoon. And look for the midterm review questions or midterm sample coming out tomorrow, I believe. All right. Thanks for coming out, everybody. Stop the recording now.